Question 7b. A second car passes B at the same time, moving in the same direction towards A. Speed of the car is given by the following model. So we're writing down that speed is equal to 10 e to the power of 1.05 t. And now they've told me v is the speed of the car, so that's why I've written down speed in meters per second, and t is the time in seconds from the instant when the car passes B. And they've actually told me what to do. They've told me to use integration to find the time it takes the car to reach A. So if I integrate, I'm going to end up with distance or displacement formula. Okay, so that's what we're going to do. We're going to integrate, and I go to my log tables in order to integrate this. And when I integrate, I end up with 10 e to the power of 1.05 t all over 1.05 plus the c. Now that's my distance formula, and because I would really like to know c, the only thing, and there's nothing else mentioned in the question, the only thing that I know is that when t is 0, my distance or displacement is 0. So when t is 0, my distance or displacement is 0. So that is 1.05 times 0 all over 1.05 plus c is equal to 0 in this situation. And you're going to clean this up, and e to the power of 0 is 1. So that's 10 all over 1.05. And I'm going to move that over, so we end up with c is equal to minus 10 all over 1.05, and you can write that as minus 0.952438 if you want as well. So I now have c, so my actual formula is, if I want distance, my distance formula. And what do I want? I want the time it takes the car to reach A. Well, what do I know there? I know the distance is 100. So if distance is 100, well then I can just start working this out. Multiply across by 1.05, and you end up with 10 e to the power 1.05 t minus 10 is equal to 105. You can add your 10. Then we can use logs here. Well, I'll divide by 10. E to the power of 1.05 is equal to 11.5. And then you can just use logs here, where you'll have, well, you have two options. You can introduce logs to both sides, or you can just, sorry, that's a t there. So if you went to your log tables and wanted to put it into log format, that's log 11.5 in the base e is equal to 1.05 times t, and you end up at 1.05 times t is equal to 2.442347. Divide by 1.05 and you end up with, and they ask you to round off to 2 decimal places, so divide that and you end up with 2.33 seconds. That's part B, part 1. And then part 2, they just suggest one limitation of using the exponential function to model the speed of the car and give a possible reason for your answer. Well, the exponential function has a limited time period of time, and the reason is, the speed isn't going to increase indefinitely. Okay, so